Hey everyone, welcome back to Game Code Mastery. Today, we are building a flexible action system in C++ that you can reuse across any project. By the end of this action system tutorial series, you'll have a fully working action system in C++ that you can reuse across any project. Let me show you what we are building with this action system and why you should care about this approach. This system will handle all actions such as jumping, dodging, and attacking. This system will also manage when different actions should block each other, when they can combo, and how they interact with and manage your character's state. For example, controlling if you can attack while dodging or while in the air. Another example is a special state that activates a certain animation in your animation blueprint, and can also tell the action system to activate a special attack action if the attack is activated while a certain state is active. This will be powered by gameplay tags, which will allow us to create smart relationships between actions. In our action data, we will have things like granted active tags, which are tags granted when the action is activated and removed when the action ends. This, in combination with the blocked tags, determines if the action can activate or not. This will give us a data-driven gameplay tag workflow for managing when actions can be activated and how actions interact with and manage your character's state, all without hard-coded dependencies or long and messy if statements. And because it's built as a reusable component, you can drop the action component onto any actor to give that actor an action system. This is architecture that can scale and grow as your project grows. Now, before we dive in, I want to let you know that this action system is actually the first piece of something bigger. Over the next several tutorials, we are going to be building out a complete Souls-like combat system by creating several standalone systems that all work together perfectly. We'll cover an attribute system for health and stamina, a hitbox system for hit detection, an enemy AI system for challenging opponents, a damage and hit reaction system, a targeting system for locking onto enemies, a weapon system for handling multiple weapons, and more. Each tutorial, including this one, is designed to be completely standalone. You can just follow this action system tutorial and walk away with something incredibly useful for any project. But if you stick around for the whole series, by the end, you'll have all the building blocks for a professional-grade Souls-like combat system. Now, this system won't follow the single responsibility principle perfectly, and that's fine. You don't always need to follow every design rule if it gets in the way of your actual goals. For us, the priorities are simplicity and keeping implementation separate from data. We'll break everything into two main classes. The action class, which will be a base data asset that stores configuration for a specific action. The second class will be an action component, which will be a reusable component that manages actions for an actor and handles what happens when they are activated. On top of that, we'll make use of gameplay tags to filter and organize actions. If you're new to gameplay tags, I recommend you check out my separate video where I cover them in detail. Okay, with that out of the way, let's go ahead and get started. To follow along, all you'll need is a third-person template setup, plus the free Paragon Greystone character from the marketplace. The very first thing we are going to do is create our action class. We can do so by selecting Tools, New C++ class, All Classes, search for a data asset, and select data asset here. Okay, let's name this ACS underscore action. And we'll put this in the folder action system. And we will make this public. So this will be in public action system. Now, you may have noticed that I'm using the prefix ACS underscore. Most projects will have a short code or abbreviation in front of their class names. For our project, ACS stands for Advanced Combat System. It keeps everything organized and makes it clear what belongs to this system. So let's go ahead and select Create Class. Okay, and now you should have the class here in your IDE. So yours might look slightly different if you're using a different IDE. So now let's go back to the engine really quickly. And let's create a new C++ class. Let's create that action system component. So put this in the same location, the public action system. Let's call this ACS underscore action system component. And let's go ahead and create class. All right, now let's go ahead and close out the engine because we are going to write some C++ code now. So it's a good idea to close the engine so that way when we finish, we can compile and open the engine. We could also use live coding, but I'm not going to do that because I've found live coding can sometimes corrupt blueprint files. So I'm probably going to stick to mostly just compiling from the IDE. Now let's go ahead and remove these comments. We won't need them. Let's go to the CPP file, remove the comments. We can also remove tick completely because we won't be using that. Let's go back here and just remove tick. Now, as I said earlier, we are going to make use of gameplay tags to filter and organize actions. So in order to use gameplay tags in our code, we are going to need to be sure to include that in our project. So we need to find our build.cs file. It should be in source, project name.build.cs. So you just need to make sure that you have gameplay tags added here. So if you don't have it, you would just add this exactly as I have it here at the end of your add range or your public dependency module names. The reason why we need to do this is because Unreal won't compile our project with gameplay tags unless it knows our code depends on that module. Adding it tells the engine that we need this module's functionality. In our case, it is the gameplay tags. Think of it like adding a library to your project so you can call its functions. Without it, the compiler has no idea what fGameplay tag is, for example. Now let's go work on our action class here. So let's start by adding a public section here. And this is something known as an access specifier. Access specifiers control who can see and use different parts of your class. You can think of them like security levels for your class members. Public means anyone can access members from anywhere in your code. A good practice is to start with private or protected by default and then make things public only when other code needs them. This keeps your classes clean and prevents accidental misuse of internal components. In our case, the reason why we are making this public is because we are going to want to access all of this from our action system component. So because of that, we are going to make it public. Now, let's add a uProperty. If you don't know what a uProperty is, the uProperty is a macro that tells Unreal Engine to manage your C++ variables, making them work with blueprint, serialization, garbage collection, and the editor. Marking a variable as a uProperty will also expose your variable with Unreal Engine's reflection system, so that the engine knows that the code exists and can manage it properly. Unreal Engine's reflection system allows the engine to examine and evaluate itself at runtime. This enables things like automatic garbage collection, exposing our C++ to blueprints, editor details panels, and more. In our case, we are going to expose this to the editor. So we are going to make this edit anywhere, which means that this property will show up in the editor details panel and also in instances as well. And then we are going to specify the level of blueprint access that this has, blueprint read only. And then category is going to equal action. And this will be a fGameplay tag, action tag. You may have noticed that the fGameplay tag here is red. And if you tried to compile this, your code actually wouldn't compile. That is because we need to include gameplay tag container. So let's go ahead and do that. Hash include gameplay tag container.h. And now fGameplay tag container is no longer red. If you don't know, hash include is a preprocessor directive that literally copies the contents of the specified file into the current source file where the hash include line is. This happens during the pre-processing stage, before the compiler translates your code into object code. The reason we need to include gameplay tag container is because that is where fGameplay tag struct is defined. Also because we are using the gameplay tag type directly by value. Now let's add a comment here so we can explain what this is used for. Action tag to find an action by tag without a reference to the object. Now let's add another U property. Actually, we can just copy and paste this. This will be f gameplay tag container. So this will be a gameplay tag container, and this one is a single tag. So a gameplay tag container just allows you to add multiple tags. We will call this one granted tags. And let's add a comment here to explain what this is going to be used for. And if you don't know what this is going to be used for, this is going to be tags added to owning actor when action starts, removed when action stops. So these tags are going to be granted and removed when the action starts and stops. This will be useful for allowing us to know if a specific state should be active while an action is active. So for example, we could say that the attack state is active while the player is performing the attack action, which will be very useful for us later when we are building out our action system. And actually, instead of blueprint read only, for this one, I'm going to remove that. That way you can't read or write from blueprint. Now let's copy this and paste it here. And this will be an f gameplay tag container blocked tags. Let's add a comment to explain what this will be used for. Action can only start if owning actor has none of these tags. So what this will allow us to do is, let's say for example, you don't want to allow attacking while dodging. Well, what we could do in this case is create a state for attacking and dodging. And we can create those states as gameplay tags. And then we can add those to the granted tags for each of those actions. For the dodge action, we can be in the dodge state. And so in our attack action, we can add dodge state to the blocked tags. So that way, dodge will block attack from being able to activate, which is going to be very useful for our action system. Now, let's add void start action. And actually, we will need to make this virtual void start action. And virtual is just a keyword that you put on a function in a parent class to say that child classes can override this function if they want to, which allows different classes to have their own version of the same function. So you should use the virtual keyword for any function that you think will need to be overridden in a child class. A good practice is to not make them virtual by default, and if you need to override them in a child class, then you can make them virtual. Otherwise, there's no need to make it virtual. In our case, we are going to need to make this virtual, so each action can have slightly different functionality. I'm also going to add a virtual void stop action. Now, since our action is a data asset and is going to be used primarily for data configuration, the only thing that our stop action and start action functions are going to do is call functions from the action system component. So that means we are going to need a reference to our action system component in our action. And an easy way to do that is to just pass it as a variable in our function. So let's go ahead and do that. So let's go ahead and add uacs underscore action system component as a variable here. We will make this into a pointer. Call this action conf. To make a variable into a pointer, you need to use the asterisk symbol in the declaration like I have here. I recommend you already be familiar with pointers as they are essential fundamental concepts for Unreal C++. But for clarity and understanding, I will provide a brief summary of pointers in C++. A pointer in C++ is a variable that stores the memory address of another variable, rather than storing a value directly. You can think of it like a street address that tells you where to find a house rather than being the house itself. It's a more efficient way to pass objects around without having to keep recreating copies. So instead of recreating copies of the object, you only need to pass around the address of the object, which is much more efficient. Now, if we try to compile this, this will actually give us a compiler error because the compiler won't know what action system component is. Now, you could fix this by adding an include up here, but I don't recommend doing that. A good practice is to use forward declaration in headers when you only need pointers or references. Save the actual include for your CPP file where you will actually need the full class definition. For declaration tells the compiler this class exists without including its full definition. Think of it as promise now, deliver later. This creates less bloat, so we will have faster compile times, and reduces dependencies as we will only be including them when we actually need them. This also prevents something known as a circular dependency, which is when two or more pieces of code depend on each other, creating an infinite loop that breaks compilation. Now, some things to note about how forward declaration works. Now, there are two ways that you can forward declare a class. You can do it exactly where it's needed, like this, and then I'm going to go ahead and copy that, paste it, and here we no longer need to forward declare it. This forward declares it for this line and every line below, not above. Because of that, I'm going to go ahead and copy that. To actually do it up here at the top of your class. So class, and then the class name here. Now we can remove that from here. You should do it this way if you're going to be using it multiple times in your header file, like we are here. Okay, now let's add another function, virtual bool can start action. So this is going to check if the action can be started. This will allow us to control when the action can be started. So I'm going to copy this and add the action component to this one as well. Virtual bool can stop action. This one will allow us to control when the action can be stopped. So that way, if we want to prevent starting or stopping the action during certain gameplay scenarios, we can do that using these functions. Let's also add a bool does satisfy tag requirements. And we are also going to add the action component here. It will also be a good idea for us to make some of these const. So can start action should be const, can stop action should be const, and does satisfy tag requirements should also be const. If you don't know what const is, const makes variables, parameters, or functions read only. This is useful for letting people know that this function is read-only and should not modify state. In our case, can start action will only need to check if the action could be started. Same for can stop, and does satisfy tag requirements is only going to check if the tag requirements have been satisfied. So these are essentially just functions that check things and they do not change things. So we can make them const. Be sure to add definitions for these functions, because if you don't, then your project will not compile. So I'm going to go ahead and do that. And for can start action, we're going to need to return a value. So let's return true. Let's do the same thing for the other ones as well. So now the next thing we are going to do is add an animation montage to our actions, because our actions will need to have animation montages associated with them. So that way, for example, the dodge action can play the dodge montage whenever it is activated. So what we are going to do is let's create another new property. Edit anywhere, category equals action. Make this class. So we're going to forward declare it here because this is the only place we are going to need it. UNM montage pointer action montage. Now we will also need some other values associated with our montage. So let's copy that. And this one will be a float. This will be the play rate. Make that equal to 1.f by default. We're going to initialize this by default as 1. Paste that here, and let's make this into a T array. This will be a T array of if names, and this will be the montage section names. So these will be the montage section names associated with this action montage. Now above this one, actually, let's create another variable. Let's make this a bool, b random montage section. By default, this will be false. And this will allow us to specify if we want to use a random montage from our montage section names. So by default, it will get from the first index, but if b random montage section is true, then we will grab a random montage section name from this array. Now you might have noticed that we used T-array here. T-array is Unreal Engine's dynamic array. It's a list that can grow or shrink at runtime. The T here in front of the T-array stands for template. And anytime you see a T prefix in Unreal Engine, it means this is a template class, which is generic and adaptable, meaning it can hold any type of data, like ints, floats, or custom objects. You may have also noticed that we have b here in front of our Boolean variable. That is also standard practice in Unreal Engine to include b in front of your variable name for Booleans. That's just b for Boolean. And you also may have noticed things like f in front of f gameplay tag container and f gameplay tag. This simply indicates that it is a struct. So those are just some standard naming conventions used within the engine. Now, something that you may notice is that all of these variables are related to each other. So since all of these variables are related to each other, it might be a good idea to make these into a struct. Because when you find yourself passing the same 3 or more variables around together frequently, they might belong in a struct. A struct groups related variables together into a single data type, which is like creating a custom container that holds multiple pieces of information as one unit. So let's go ahead and create our f-action-montage struct. Let's cut these variables. You might be wondering, where should we define our struct? Well, we can define our struct here in our action. And the reason why is because we know our action-montage struct is only going to be used in our action and will not need to be used outside of the action. Now, if you ever think that you will need to use this struct outside of the action class, then it would be a good idea to define the struct in something like a types header file. So that way, you only need to include the header used to define the structs without including the entire class. But in our case, we don't ever plan to use the struct anywhere else, so it's going to be fine to just define that here in the action class. Or at least that's the plan for now. We can always change that later if we need to. So let's add a u struct to be blueprint type. So that way we can expose the properties within this struct to blueprint. This will be a struct if action montage. And let's add generated body here, because you need to add generated body to structs. If you want to know what this is essentially a macro that if you hover over it, you can see Unreal Engine replaces this with all the necessary boilerplate code that gets generated for the type. So this will just generate some necessary code for our struct. So now we can paste all of those variables that we created earlier right here. Instead of setting these values directly, let's set them using a constructor, or rather an initializer list. To understand what an initializer list is, you must first understand the concept of a constructor. A constructor in C++ is a special type of function that runs automatically when you create an object, and its job is to initialize that object's data. So a typical constructor looks something like this. Type in the name of your class, or struct in our case, f-action montage, open and close parentheses, and then curly braces. And here you can set the default values, such as action montage equals null pointer, play rate equals 1.f, and so on. So you just add any variable that you want to initialize in the constructor. However, for structs, instead of defining the default values with a standard constructor, it is actually good practice to define the default values through an initializer list. An initializer list is a special syntax used in constructors to initialize class member variables before the constructor body executes. Using an initializer list is considered best practice because it constructs a variable with the intended value from the start rather than default constructing it and then assigning a new value in the constructor body. This is also consistent with Unreal Engine standards, Unreal Engine's coding style often prefers initializer lists for clarity and performance. So let's follow those Unreal Engine standards and good practices by creating an initializer list. The way to do that is action montage. That's the name of your struct, and then open close parenthesis, and let's add colon, and then the name of the variable that you want to initialize, action montage, and then in parentheses here, let's initialize our action montage as a null pointer, null PTR, and for the ones below the first one, add a comma, and then variable name, play rate. We're gonna make this 1.f, comma, the random montage section be false by default. Let's do the montage section names. We can just initialize this as an empty array. After that, let's add open close curly braces. One benefit to creating a struct in C++ compared to Blueprint is that you can add functions to structs in C++. So let's take advantage of that by adding a few helper functions to our action montage struct. One useful helper function to have will be to know if the montage is valid or not. So let's type in bool, because this is going to return a boolean, and call this is montage valid. We will make this const, and this will return if action montage is not equal to null PTR. And the next helper function will return the last section index. We need to return an int32, get last section index. And this one will be const. And the way this is going to work is it's going to return montage section names. So this is the montage section names array that we created earlier. And we are going to access this array with the dot operator. If you don't know what the dot operator is, in C++, the dot operator is called the member access operator, which is different from things like the scope resolution operator and the arrow operator, which we will talk about more later. But essentially, the dot operator is used when you have a direct object instance. In our case, we created an array variable of fnames, which created an instance of that type. And since we have direct access to the instance, we can use the dot operator to access its members. And this one has a member that we need to access, .num, and then we need to do -1. The reason why we need to return the montage section names as num -1 is because of the way arrays work in Unreal Engine C++. The first element in an array starts with index 0. The num function returns a number of elements in the array. For example, an array with 4 elements will return 4, because the index is 0, 1, 2, 3, which is 4 elements, but the last index will be 3. That's why we need to subtract 1 from num to get the last index for the array. Okay, and the next helper function is going to be an int32, and this one will get rand section index. This will be const, and right at the start, we are going to check if montage section names dot. We're using the dot operator, and we are going to access a function in the array. This is empty. This lets us know if the array is empty. And if it is empty, you're going to return 0. Or actually, we could return -1. That way we can know this failed. Okay, and now we are going to create a local variable, which is going to be an int32, be a rand index. And we are going to have this equal fmath, and we are going to use the scope resolution operator. The scope resolution operator accesses members of a type itself. Scope defines where something can be accessed in your code. And the scope resolution operator is used to define or access members like variables, functions, or classes that are outside the current scope. In our case, we don't have a direct object instance of fmath. We are going to access its member functions by using the scope resolution operator. And we are going to use rand range. We can use a keyboard shortcut in Visual Studio. If you're using Writer, you can set the key map to Visual Studio keyboard shortcuts. Pressing Ctrl-Shift-Space shows us the inputs for the function. In this case, we have a min and a max. So the min will be 0, and the max will be get last section index. Now we don't plan to change this later, so it will be a good idea to go ahead and make this const. Okay, and now we need to check if montage section names, you're going to use a function called isValidIndex. You're going to check, is the rand index a valid index? We actually are going to check, is it not a valid index? So we are going to use a not operator here. And the not operator basically flips a Boolean value to its opposite, turning true into false and false into true. Essentially what we are doing is we are returning if the random index is valid. If it is valid, then that will make this false. If it is not valid, it will make this true. In which case we can return -1. And if we make it this far, we can return the rand index. And the last helper function we are going to create is going to be used to get a montage section name. So this will return an f name. This will be get montage section name. And this will have an input variable, const int32 section index. This will be a const function. Okay, let's check if montage section names is empty. If it is empty, we return name underscore none, which if you don't know what that is, this is a global variable, which is essentially a special 0 value, meaning no name. Now let's create an int32 selected index, and this will be equal to section index. And since we have a Boolean, the random montage section, since we have that Boolean, let's go ahead and use that. The random montage section. If that is true, then the selected index is going to be equal to get rand section index. Then we're going to do a check if, and this check will do a similar check that we did before, is this one. We're going to copy that and paste it here. And instead of the rand index, let's use the selected index. So if the selected index is not a valid index in the montage section names array, then we return name underscore none. And if it makes it this far, then that means we have found a valid section name. We can return montage section names. And to access an array, we can use brackets like this and the index inside the brackets, which in our case is selected index. Okay, and that should be all the helper functions we need for this struct. The next thing we need to do is go down here to the blocks tags, right underneath that, and let's create another U property. Let's make this, to make this one similar to the U property we used up here for the action tag. And this will be an if action montage. Before we compile our code, let's make an improvement to our does satisfy tag requirements function. The only thing this function will need to do is check the active gameplay tags from the action system component. And since we will only be calling this function from the action system component, we can simply pass the action system component's active gameplay tags through this function instead, because we don't need to access the action component just to check the tag requirements. What we are going to do is replace this with if gameplay tag container. Let's call this active gameplay tags. While this is cleaner, this is also less efficient, because if you pass a variable into a function by value, the program makes a full copy of the data. That's why in C++, and especially in Unreal Engine, it's good practice to pass large data types, like structs or classes, by reference. We can pass by reference by adding an and sign here. Passing by reference is more efficient because it avoids copying data. You are giving the function direct access to the original memory instead of making a duplicate. But since you are working with the original memory instead of making a duplicate, this means any change you make to the reference will reflect back to the original value. This can be useful if that's what you want. However, it could potentially be dangerous if unintended. This is because modifying a reference can lead to data being modified in places it was never meant to be modified, which can lead to unintended bugs and issues that can be hard to track down. However, you can fix this by using const references, because const does not allow the value to be modified. This gives you the efficiency of referencing without the risk of accidentally changing anything. It is safe, efficient, and a best practice way to write your code. In fact, this is a technique that Epic often uses in the engine code as well. So let's go ahead and make this const and make use of that ourselves. And let's copy all of this. And here in action.cpp, let's paste it here. Okay, and instead of simply returning true, let's actually make this do what it's supposed to. Let's return if the active gameplay tags dot operator has any. This function checks the active gameplay tags that we pass into this function has any of these tags. It'll be the blocked tags. And we want to make sure that it does not have any of the blocked tags. So let's add a not operator here, because the intended use of this function is to check if the tag requirements are satisfied. In this case, the tag requirements are only going to be satisfied if the active gameplay tags does not have any of the blocked tags. Okay, let's go ahead and compile by holding Control F5. Should compile and launch the editor. Mine compiled successfully. If yours didn't compile successfully, then you may have made some minor mistake. Just note that in C++, everything needs to be precisely correct. If you made any sort of minor mistake, then yours may not compile. So I'm going to go ahead and scroll through my class so that you can reference it and see if you made any mistakes. Okay, here in the engine, in your project folder blueprints. Now you don't need to use the exact same names that I do, just whatever your project folder name is. In blueprints, create a new folder, call it actions. These will be our project specific actions. That's why we are going to put it in our project folder blueprints. Okay, here in the actions folder, miscellaneous, data asset, and here we can see ACS action. Select and call this jump action. Okay, let's open that up. This is what an action looks like in the editor by default. This is all the data that we have. And if we hover our mouse over, you can also see those comments that we added in the C++. You can see that the action tag is used to find an action by tag without a reference to the object. Granted tags are tags added to owning actor when action starts, removed when action stops. Block tags, action can only start if owning actor has none of these tags. That way, anyone filling out this data can easily know what these are used for. This is going to be an example jump action. For the action tag, we can add a tag by selecting plus. Source will be default gameplay tags, action.type.jump. And once you've created that, select action.type.jump. You may have noticed that I created a normal attack tag as well. We do not need that right now. Right now, we only need the jump tag. And if you need an action montage, you can select one. And if you need montage section names, you can add them here. We can set the play rate, and if we want a random montage section or not. For our jump action, we will not use an action montage, so we can leave that blank.